What's happening, dogs? Mr. Allen here. We are about to solve for x in this beautiful rational equation here. We're going to get our least common denominator, our domain restrictions. Oh, it's going to be a blast. All right. First thing when solving rational equations, we got to figure out our least common denominator. So I'm going to have to factor this guy right here. The other two cannot be factored. I'm going to factor anything that can be factored in my denominator. All right. So I'm going to take out an x for this one, and I'm left with x plus 2, a little GCF action. Now, if you look at the rest of our equation here, I've got an x here, I've got an x plus 2 here, I have an x times x plus 2 here. My least common denominator is this guy right here. So it is x times x plus 2. Now, it's not always one of the fractions has the least common denominator. Sometimes you have to piece things together. In this case, it is there. All right, so that's pretty dope. And from here, I can actually get my domain restrictions. Right? Domain restrictions are anything that's going to make my denominator 0. The reason being, I can't divide by 0. If I divide by 0, it's undefined. All right? So my domain restrictions come from making my denominator 0, which would be 0 in for x, right? Here, that would make it 0, right? This would make the whole thing 0, or negative 2 as well, because that would make this guy 0. It would also make this fraction right over here 0. So x cannot equal 0 and negative 2. All right. I find that the easiest way to write my domain restrictions. Some people like to use interval notation. I feel like it gets messy for this, so that's what I'm going to do. It's my video. I get to choose. What's up? All right. Let's continue. Shall we? We shall. Now, one strategy for solving rational equations is getting a common denominator throughout the entire problem. And that's what we're going to do in this particular video here. So I'm going to multiply by whatever we need. So this one here needs an x plus 2. I can multiply numerator and denominator by x plus 2. All right. Multiplying by x plus 2 over x plus 2 is equivalent to multiplying by 1. Multiplying by 1 doesn't change anything, right? It's still itself, right? Anything times 1 is that anything. So it's just a little creative form of 1 to get common denominators. I'm also going to do the same to this one over here, x over x. And this guy right here is good to go, right? It already has the x times x plus 2. So let's rewrite this thing with all common denominators now. I've got the first fraction here is 3 times x plus 2 over x times x plus 2. I've got x times x. I'll just leave it as x times x. We know that's going to be x squared, but we'll do that in a sec here. All right, I've got x times x plus 2. This last one here does not change. It's 4 divided by x times x plus 2. All right, so are all my denominators the same here? Yes. So would it make mathematical sense that if all my denominators are the same, equal, then I just need to figure out what makes my numerators equal, right? I just have to figure out what makes my numerators equal. So we're going to drop all our denominators here. I'm going to rewrite this with just our numerators. Beautiful, wonderful. I'm going to make that x squared right now because it's bothering me seeing x times x equals 4. And now I can solve this thing just like an Algebra 1 problem. I'm solving a quadratic equation, which is a little scary. I'm going to distribute that 3 first to get 3x plus 6 plus x squared equals 4. And you could have distributed that here before we rewrite it, but I'm showing a few extra steps, okay? Once you get comfortable with it, then you can skip some steps here and there, but be careful. All right, I got a quadratic. We always freak out when we see quadratics. We don't remember how to solve them unless we're in our quadratics unit. All right, we got to set them equal to 0. So I'm going to subtract 4 on both sides, and I'm going to rearrange this thing. X squared is going to be first, the 3x is going to be second, and then 6 minus 4 is positive 2, and that all equals 0. Beautiful, wonderful, and fantastic. Now I can factor this, all right? And this is called standard form or descending order or general form. Different names, right? Different names on the mathematical streets. All right, so what multiplies to 2 and adds to 3? That's going to be x plus 2 and x plus 1. All right, 2 times 1 is 2. 2 plus 1 is 3. Yay! All right, so now I can set x plus 2 equal to 0 and x plus 1 equal to 0. So I'm going to get x equals negative 2 for this one, and I'll get x equals negative 1 for this one. Now, before we circle these answers, we got to check back at our domain restrictions, right? Domain restriction, matches this guy right here. If I were to plug negative 2 into the original equation, my denominator right here and here would be 0, thus making it undefined. So I have to omit that right there. That is called an extraneous. Sound it out, spell it out. That is an extraneous solution right there. Now, fun fact, on a test, or even like the SAT or ACT, I've seen questions where they say, which of the following is an extraneous solution? And negative 2 would be one of those choices from A, B, C, D, or E. So that is a question we can ask you, or the SAT or ACT can ask you. So be aware of what that's called. Not just that we omit it, but it is called an extraneous solution. All right, our only working solution here for this one is going to be that x equals -1. That's it. That's the only one you should write on your answer line or circle or whatever it is. The other one is not a working solution. It is an extraneous solution. That's dope. I've said extraneous enough, I think. Extraneous. All right, I'll see you dogs later. Have a wonderful day.